Hello, students. Today we're going to be doing our test corrections for Chapter 1 test. So, if you work with me to correct your test, simplify the expression, write your answer using only positive exponents. So, the very first step that we're going to do is to just write everything, move it to the correct space. So, I've got 12 stays on the top. I got this x to the fifth goes to the bottom and becomes positive. And then y to the third stays on the top. 3 to negative 2. So I have 3 squared goes to the top, x to negative 2, x squared, and y to the fourth. There. So I've just moved everything, top and bottom. And now I'm going to simplify this. So I have 3 squared, which is 9. So I have 9 times the 12. Then I have y to the third and y to the fourth. So that makes 7 total y's up top and 2 x's. And I still have this x to the fifth on the bottom. Can't forget that one. Simplify. So 9 times 12. 120 minus 12, right? So I have 108 on the top. And then 7 y's on the top. And then I have 2 x's on the top and 5 on the bottom. So 2 minus 5, so I'm left with 3 on the bottom. There's my answer. All right, let's go for number 2. Number 2, I have 5x to the fourth, y to the 0, and all of that to the negative 3. So the very first thing I'm going to do is I'm going to move it all to the bottom. Well, y to the 0 is 1, so I don't even need to write that. So now I have no negatives. So 1 over 5 to the third, x to the fourth to the third, x to the 12th. 5 to the third, 5 times 5 is 25, times 5 is 125. There you go. All right, let's do this one, number 3. So I have a negative here. So the first thing I'm going to do is I'm just going to flip everything. So I have 1 on the bottom, and I have 2a to negative 2. Oh, gosh. Okay, so I still have negatives. So the first thing I did is I got rid of this negative. So I flipped everything. Now, I have to carry this to the bottom. So I have 2 over a squared. And that's all to the third power. And now, I have no more negatives. So I have 2 to the third power over a squared to the third power. 2 to the third power. 2 times 2 is 4 times 2 is 8. So I have 8 over a squared to the third, so that's a to the sixth. All right, there's 1, 2, and 3. Number 4. Actually, you know what? I will put these in here. So number 1 is 108 y to the 7th over x to the 3rd. Number 2 is 1 over 125 x to the 12th power. And number 3 is 8 over a to the 6th power. Oops, burp, burp. There it is. Okay. Number 4, rewrite the expression as a power of a product. So this gets distributed through all of the parentheses. So I have 3 squared, x to the fourth to the second, so that's 8, y to the second to the second, that's 4. So I have 3 squared, so that's 9, x to the 8th, y to the 4th. All right, so same thing here. I'm going to distribute this to every new piece in our equation. So I have 4 to the 4th, x to the 12th, y to the 16th. So it's 4 times 3 because it's exponenting an exponent. 4 to the 4th, 4 times 4 is 16, times 4 is 64, times 4, it's 256, x to the 12th, y to the 16th. Okay. Evaluate the expression. Okay, so the first thing you're going to do is you're going to rewrite these. Whoa. So 27 to the 3rd root, and then times -2. Wow, that's a lot going on there. So the first thing I'm going to do is I'm going to cube root this. So what times what equals 27? 3 times 3 is 9. 9 times 3 is 27. So it's 3. So this equals 3 to -2, which equals 1 over 3 squared, right? So I got rid of my negative. So I now have 1 over 9. Oops. Oh gosh, did I mess something up? Oh no, that is this one, number 6. 1 over 9. Okay. Let's go ahead and do number 7. Oh gosh. Okay, number 7. So I have a negative on the outside, negative 125. So what times what gets me to 125? I think 5 times 5 times 5, or -5, I'm sorry. -5 times -5 times -5. So that gets me there. So what I have, the 3rd root, or the cube root of -25 is -5. Now, that's what's here inside the parentheses. Now, outside the parentheses is this negative. So I have to put the negative there. So I have -5, so I get +5. Okay. Make an input-output table and graph the function. Describe the domain and the range. All right, so 1/2, 2, so I have -1. So what if I put -1 right here, it'd be 1/2 times 2 to -1. So it'd be 1/2 times 1 over 2, right? Because -1, I have to flip this. So 1/2 times 1/2, that'd be 1/4. 0. 0 makes this a 1, right? 2 to the 0 power is 1. So this would be 1/2. 1. So I'd get 1/2. 2 to the 1 power is 2. 1/2 times 2 is 1. And then the next one I get 1/2 times 2 squared. So I get 1/2 times 4, I get 2. And the last one I get 1/2 times 2 to the 3rd. 2 times 2 is 4, times 2 is 8. So 1/2 of 8. So I get 4. Bing, bing, bing. So now I graph that. Fun. -1, 1/4. 0, 1/2. Maybe it's a little bit lower because this is 2 right here. So that'd be 1/2 would be there. This would be really. And then I have 1, 1, 2, 2, 3, 4. So I see I'm starting to grow. And if I were to put a 4 in here, 1/2, times 2 to the fourth. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 1 half 16, so that'd be 8. 4, 8. So you see this exponential function like that. So our domain, which is our x values, it goes on this way forever. And if I keep going this way forever, this will actually end up covering all my x values. So all real numbers, or as some people like to do, the r. Then my range is my y values. My y will never actually hit 0. It gets so close to 0, but it'll never actually hit 0, so y is greater than 0. It's not equal to. So the domain and the range, y is greater than 0. All right, you do not have to do number 9. Moving on. State the domain and range of the function. Evaluate the function when x equals -2, -1, and 3. So this one we don't need to graph. So when x is -2, so that would be this one. So I have 3/4 times -2 minus 1. So when x is -2, my y is going to be, that would be -6/4 minus 1. So -6/4 minus 1, I can put this as 4/4, so -6/4 minus 4/4, so I get -10/4. -10, well, -10/4 would be -5/2. Okay. And if it's -1, well, -1 is this one also, so I have so that would be -3/4 minus 4/4, so that'd be -7/4. Okay, and 3. Well, that's the same one. So we have 3/4 times 3 minus 1, 9/4 minus 1. So it's 9/4 minus 4/4 is 5/4. Okay. There you go. Number 11, graph the function. So first thing I'm going to do, x is greater than 0. Oh, well, okay. There's my boundaries. That's not as much fun. Okay, so for this one, I have a slope of 2/3, and I have a y-intercept of -5. 2, 3. And 2/3. 1, 2, 1, 2, 3. There's my line. I'm going to have to erase it somewhere, so let's see. If x is greater than 0, so if it's greater than 0, that means that this point is not filled in. So I have an open circle. And if it's greater than 0, we go like this. So there's one of them. And then my other one, I have a slope of -1/2, y-intercept of 3. So there's my 3, and -1/2. 1, 1, 2. 1, 1, 2. Okay. If x is less than or equal to 0, so I got to take out the less than, the greater than. Now it's equal to, so I put equal to. There's my line. So I just graph this piecewise function. All right, find the inverse of this function. I will show you how to do it in two different ways. First, I'm going to switch my x's and my y's. So I'm going to say x equals 4y plus 2. And now I have to solve this for y. Minus 2 on both sides. I have x minus 2 equals 4y divided by 4. So I have y equals 1/4 x minus 1/2. And then I could graph this by my slope is 1/4. My y-intercept is negative 1/2. Don't forget, I could rewrite this as y equals 1/4 x minus 1/2. So that's my inverse function. Now the other way I could do it is I could plug in x's and y and flip them. So let's do -2, -1, 0, 1, 2. 4 times -2, that's -8, plus 2 is 6. -4 plus 2 is 2. 0, 4 times 0 is 0. 0 plus 2 is 2. Uh-oh. I'm sorry, -4 plus 2 is -2. 1, 4 plus 2, that's 6. 2, 8 plus 2, that's 10. So there's my function. There's this function. But the inverse, don't forget the inverse. I wish I had enough room right here. The inverse is, I just flip these. So I have 6, -2, -2, -1, 2, 0, 6, 1, and 10, 2. So we can graph these. Wait a second, that's something's wrong here. Okay, sorry. Trying to check my math. Let's see if it's right. Okay, -2, 6. Okay, that's off the chart. So -1. Wait, how is it -2? That would be -6. Be off the charts. -1, -2, 0, 2, 1, 6. Here goes 1. If you remember, my inverse is going to reflect across. It's going to reflect across this. So I got 6, -2, nope, -2, -1, -2, -1. That looks good. I have 2, 0, and I have 6, 1. Okay. No. Would you look at that? Sure enough, that reflected there, that reflects there. So there you have it. There is your reflection. I'm sorry, your inverse. All right. If you have any questions, give me a call, or give me a Zoom, or email me, or carrier pigeon it. You can mail it. That'd be funny if you mailed me a math question.